Hello and welcome to the course. The first topics we're going to be talking about is the Internet and the World Wide Web. The materials used in this course are used by permission from the book Web Programming Step by Step. You can check out the website for additional information and materials. The first topic is the Internet. The Internet is really composed of a connection of computer networks using the Internet Protocol, or IP for short. The communication protocols that are used could be TCP or UDP. We'll talk more about those later on. HTTP is a communication, the protocol to get the data from the web browser. You might use FTP to transfer files, or for email, you could do POP, IMAP, or SMTP. We often could think that the Internet and the World Wide Web are the same thing, but there is, a difference. The Internet is the physical infrastructure and the communication of the devices. The World Wide Web is really a collection of information, documents, images, and they are linked all together. The World Wide Web sits on top of the Internet. The Internet really began in the 60s and the 70s with the U.S. Department of Defense, as it created the network to send electronic mail and to transfer the files from one location to another location. The World Wide Web was created in the late 80s and the early the 90s. After that, the popular web browsers were released, such as Netscape and the Internet Explorer, which made it usable by the common person out there. Some of the early startups that are still around are Amazon.com and Google. The hamster dance was an interesting phenomenon. This was the first web page that ever went the viral back in the 99. For some entertainment, you should click on the link. Since the Internet is really a collection of the networks, a key aspect is that these the networks can stand on their own. They can either be connected over to the larger Internet the network, or they can remain alone. Also, computers can dynamically join and leave the network as they choose. There's no gatekeeping procedure that says one can and another one can't. It's built on open standards, which means anyone can create a new Internet device. There's also a lack of the centralized control, for the most part, so no organization or group can control what the Internet is. And everyone can use it with simple, the commonly available software. Some of the organizations and groups that do have a controlling effect on the Internet are things that actually help the Internet to function as a whole. For instance, IETF, they control the standards for the Internet the protocol, which ensures that all devices can communicate. And also, the top level, the domain names, is also another controlling effect. And this organization, ICANN, decides who can have, if somebody will create a .com or .net or .cn or .abc. Something that is important to us in this class is the web standards by W3C. They set the standards of what is acceptable in the documents on the Internet. For instance, a web page, what tags can it have? Because the standards say that the web browser, they have to know what is in the document that the web browser can interpret in the specific way. The Internet Protocol, or IP for short, is the protocol for attempting to send data between two computers. Every computer on the network or the Internet has its own unique address. When it joins a network, this address is given to it. A 32-bit address is in the format listed below. This is IP the version 4, but now more commonly we are beginning to see the IP the version 6 because they ran out of 32-bit addresses. The internet is composed of different the layers, which allows the data to be transmitted from one location over to another location. The link the layer's job is to move packets between two different hosts. This is from one computer to another computer, and it directly interfaces us with the hardware components. The internet, the layer, takes it from one network to another network, or across the networks as it reaches its destination. The transport, the layer, acts like a vehicle. It ensures that the data leaves its host and reaches its destination intact. If the data gets lost or corrupted along the way, it has to go back and get it again to ensure it arrives at the destination as it left. The application layer tells how the data, for instance, using the HTTP, which is the web, the browser, how the data can get from the web server to the browser, or FTP if you're doing file transfer as well. The transmission of the protocol adds multiplexing and guarantees that the message rides on top of IP. It allows multiple the computers to use the same IP address. So every computer can have one IP address but communicate on the wide array of methods. For instance, port 80, you could be using port 80 on the web browser, which is what most standard web traffic uses to browse the web. At the same time, you could be using an email the client to download email in the background. A TCP, one of the important things about it is it ensures that the data is delivered intact to the destination. If any of the data is corrupted or changed, it has to go back to the beginning and make sure it will deliver it fully intact. Well, the UDP is not like that. If you're playing a game or streaming audio or like the video, if some data is lost or corrupted, it's not really a big the problem because there might be a small blip in it. In the UDP, the later the data is more important than the earlier the data.